The goal of this video is to help you with figuring out how to do what I call money and ticket problems, which is the first problem. And in the second slide, we'll do what's called a mixture problem, which is a very similar problem, except that the numbers don't need to work out evenly. Obviously, if you're talking about this first problem with dimes and quarters, you're going to have some whole number of dimes and some whole number of quarters. Whereas if you're talking about a mixture, you could have a fraction of a pound or a fraction of a kilogram of some blend of peanuts and raisins, as is in the second example. So let's take a look at how these problems work. The first thing you want to do is define your variables well, and it's asking how many dimes and how many quarters he has. So you're going to want to start out by saying D equals the number of dimes that Patrick has, and Q equals the number of quarters that Patrick has. Once you've defined your variables well, you can write two equations, one that's keeping track of the number of coins and the other that's keeping track of the value of the coins. So keeping track of the number of coins is easy. It says Patrick has 15 coins. So you'd simply say that D plus Q equals 15. Now, keeping track of the money, one way to think about this is to think, how would you count how much they're worth if I handed you a pile of dimes and quarters? Well, you'd sort them out and you'd say, well, here are all the dimes, and you'd count the dimes, which is D for the number of dimes, and then you'd multiply that by 10 cents. So you'd simply say 0.10D is the value, this is the value of all your dimes. Okay, so value of dimes, and you would add that to 0.25Q, which is, of course, then the value of the quarters. Well, if that's the case, then you can think about this as the value of all the dimes plus the value of all the quarters equals the total value of all the coins, which in this case is 225. Now, there's a couple reasons I chose this problem. One is that you need to be careful writing these as decimals. If you're saying the value of a dime is 10, and then you said it was 225 was the total, then you'd be using the wrong order of magnitude. These are dimes, so they're worth 1/10 of a dollar, or 0.10. So you could, of course, multiply both sides of this equation by 100 and get an equivalent equation, which would be 10D plus 25Q equals 225. So this one's counting in pennies, and the other one's counting in dollars. So remember, this is counting the number of coins, and this one is counting the value of the coins, so it's looking at dollars. Okay, and this one's counting in cents. So you could use either of those, and it would be totally fine to do so. Now, what we want to do is use our substitution method, but you'll notice that the first equation, D plus Q equals 15, is not designed or ready yet to substitute for, because you don't have D equals some stuff or Q equals some stuff. But that means you can simply solve that equation, and if you solve it, underneath it you're going to see that if I subtract Q from each side, I'm going to get that D is worth 15 minus Q. That is, I wrote a smaller q there, but I mean a lowercase q, but it doesn't really matter. Nevertheless, what that's really saying is that the number of dimes is 15 minus the number of quarters, which of course is obvious. But that gives us something ready to substitute. That means we can take 15 minus q and substitute it in for d into either that equation or that equation. Now we're going to do it in the lower equation so we don't have to mess with the decimals. So what that means is we're going to get 10 times 15 minus q plus 25q equals 225. then we simply solve this equation. And what we've accomplished is, of course, getting one equation in only one variable. We can solve this easily. We distribute. We get 150 minus 10q, be careful with your signs, plus 25q equals 225. Collect your q's and you're going to get 15q and subtract 150 from both sides and you're going to wind up getting 15q. And since I'm running out of room, I'll do this all in one step, equals 75. When we divide each side by 15, this means that we're going to get q equals 75 divided by 15, or 5. So there are 5 quarters, and that means, of course, you can go back and plug in 15 minus 5 and get 10 dimes. It would be useful to check that, of course, we've got 15 total coins. That part's obvious. And if you go back and think, well, 10 cents times 10 dimes is $1 in dimes, and 25 cents per quarter times 5 quarters is $1.25, and $1.25 plus $1 is, in fact, $2.25. So the 2 steps that are involved here are writing the equations that are clean, one keeping track of the coins and the other keeping track of the value of the coins, so number of coins and value of coins. And then there's that little tweak of making sure that you get ready to substitute right here so that you've now got it solved for D. You could have, of course, subtracted D from both sides and solved for Q and then substituted in for Q, but either of those is an option. Okay? We'll take a look at the next slide for a mixture problem. So here's a very similar kind of problem that I call a mixture problem, and we're going to say then that R equals the number of raisins, number of pounds of raisins, and of course then what are the other ones? Peanuts. So we'll say P equals number of pounds of peanuts. So we're going to need to once again write 2 equations since there's 2 kinds of items being mixed here. And this is going to allow us to write the equation that says the total number of pounds is 50 pounds. So that simply says R plus P equals 50. And like on the previous slide, we're going to solve this, quote unquote, for one of the variations here. And so what that means is we'll be able to turn this into R equals 50 minus P, and we'll be able to substitute that in. Our other equation is going to keep track of the value of all the mixture, which means that you have R pounds of raisins at $2.10 per pound, $2.10 per pound. So that means we're going to get 2.10 R. That's the value of all the raisins in the mixture. And we're going to get $1.20, so 1.20 P. That's the value of all the peanuts. So value of all the raisins plus the value of all the peanuts is what? Well, it's the total value of the mixture. So you have to be careful here. It's $1.47 per pound, but it's times 50 pounds. That you're going to want to double check how much that is. That's what a calculator is useful for. So let's do that. Times 50. That's going to be $73.50 worth of mixture. So not only have we figured out 2 equations, but now we're ready to substitute, and it looks very much like our situation from before. Now remember, the difference is this may or may not come out evenly. Whereas in the previous one, you're going to have to get a whole number of dimes and a whole number of quarters. So when we substitute here, we're going to take 50 minus P, and we're going to stick it in for R in this equation. That's going to give us 2.10 parentheses, 50 minus P, close parentheses. Don't forget your parentheses. 120P equals, and I'm just going to write 73.50. So now we need to do a little distributing, and we're going to get 2.10 times 50, and that's going to give us 105 minus 2.10p plus 1.20p equals 7350. Now, we're going to collect our p's. Be careful here because of the signs. The 2.10p is negative and the 1.20p is positive. So that's going to give us negative 0.90p. And I'm going to subtract 105 from both sides. So that's going to give us 7350 subtracting 105 is 3150. But of course, it's negative. So don't panic. If you keep good track of your signs, you should be able to find out that all of these work out appropriately. So 3150 divided by 0.9 is going to give us 35. So this one does turn out to be a nice round number. So we're going to get P equals 35 pounds of peanuts, which means, of course, that there are 15 pounds of raisins, since there are 50 pounds altogether. And you can go back and double check for yourself that $2.10 a pound times 15 pounds of raisins plus $1.20 per pound times 35 pounds of peanuts should give you $73.50 worth of mixture. Hopefully this has made clear how to do these problems and what the process is for substituting and writing the equations. In this one, you're keeping track of the number of pounds and you're keeping track of the value of the mixture. So pounds in the mixture and value in the mixture. I hope this helps.